Good day, and welcome to my webinar on Solid Edge Electrical Design. My name is Gary Wilson, and I'm an application engineer at Kaizen PLM, with their sister company being Park Electrical Services. I'm also joined today by Frederic Beauvier, Paul Abbott, and Anthony Royden. Frederic is the Siemens Business Development Manager for Solid Edge Electrical and Flow EFD, while Paul Abbott is the Siemens Technical Manager for Solid Edge for the United Kingdom and Ireland. And I have Anthony here, who's the Technical Director of Kaizen PLM. And he would just like to mention a few words before I begin presenting.
Thanks very much, Gary. I'm Anthony, Anthony O'Riordan from Kaizen PLM. I base myself from County Limerick in the Republic of Ireland, and Kaizen PLM are going for over 4 years now. We're a Gold Solutions partner for Siemens Industry Software. As Gary mentioned, we're a sister company of Park Electrical Services and Underwoods in the UK. And we deliver the full portfolio of Siemens industry software products. We're fully supported by a global team of experts at Siemens. So we do CAD, CAM, 3D simulation, product lifecycle management, manufacturing execution systems, really a full suite of engineering and manufacturing software. We also absolutely love to work with SimCenter 3D, for thermal simulation, flow simulation, acoustics, electromagnetic analysis, you name it. So if you have any requirements at all for engineering software, just let us know and we'll see what we can do for you. Thanks again. Now over to you, Gary.
Great. Thank you, Anthony, for that introduction. And now I'd like to go into a quick discussion around today's agenda for Solid Edge Electrical. I'll be doing another quick introduction at the beginning. After that, I will be discussing some interesting industry trends with regards to electrical design. Then, I'll be discussing 3 benefits of Solid Edge Electrical and doing 3 demos around that. And then towards the end, I'll be discussing some new features and doing a demo around the new features. And there'll be a Q&A at the end. If you don't mind, while I'm presenting the webinar, if there are any questions that you need to ask, if you please just put them in the chat and we'll do our best to answer them during the webinar, or at the end, or a little bit later. Great. Okay, just a quick introduction about me. My name is Gary Wilson, and I worked for almost 20 years at the Siemens Digital Industries Factory Automation Division in Johannesburg, South Africa. And during those years, I was exposed to various different industries, ranging from automotive to food and beverage to mining and various others. I also evolved into an automation system specialist role, where I did PLCs, SCADA systems, HMIs, a bit of DCS, and even a bit of digitalization and other related systems. I did field service for a short while. I even worked on an automotive project, Mercedes-Benz, for a short while. And towards the end of my career, I moved into a portfolio consulting role within our HMI division. I am a registered professional technologist with EXA, and I'm also registered with Engineers Ireland as an associate engineer. My work interests are virtual commissioning, digitalization, and additive manufacturing. Well, let's give you a quick summary again around who is Kaizen PLM. They are Siemens Digital Industries Software Gold Solution partners, as Anthony mentioned earlier, and they're into design, manufacturing, simulation, and they provide PLM solutions that are supported by the many specialists from the Siemens DISW division. They are also smart additive manufacturing product specialist partners for the United Kingdom and Ireland, and that's where Kaizen AM comes into that part of the business. And as mentioned earlier, their sister company, Park Electrical Services, which has also recently acquired Underwoods Electrical Distributors in the United Kingdom, has offices in Aberdeen, Belfast, Dublin, Glasgow, and Wrexham, while Underwoods has offices in many different locations within the UK. And finally, they're also into 3D scanning, sales, and services. Looking at the digital innovation platform, we can see that the Siemens software portfolios consists of a lot more than just CAD. Siemens are one of the largest engineering software companies in the world, and they offer everything from manufacturing execution systems to electronic design and low-code app development platforms. Why is digital transformation so important? Well, the IDC Global Survey was done for 420 small and mid-sized manufacturers in 2018. And here were the results. 90% of these manufacturers were allocating a budget for digital transformation. 50% were actually having dedicated staff for digital transformation. And with regards to disruption, 46% reported that digital technologies were leveling the playing field versus large companies. Talking about the digital innovation framework again, one digital software solution I'll be presenting today is the Solid Edge portfolio. And in this portfolio, we have packages for mechanical design, electrical design, simulation, computer-aided manufacturing, technical publications, data management, and the Solid Edge portal, which is our cloud-based collaboration framework for Solid Edge. And as I mentioned, today I'll be focusing on electrical design in Solid Edge. So let's start talking about some industry trends that are impacting electromechanical design. An interesting industry trend is about the increasing use of electrical components in products. And these electrical components are moving more into manufactured products. And the number of electrical components per product is also increasing. And it's for all these different industries here, like automotive, aerospace, defense, networking, industrial, energy, consumer products, and there are various others. And why is this happening more and more these days is because this whole new IoT space we're moving into as well. And this means products need to be more connected. They need to be more intelligent. They also need to provide new features for their customers. And yes, it's a trend that really is going to grow and grow. With regard to the trend of increasing use of electrical components, products are increasingly being differentiated by their electrical content. And the Daimler R&D CIO mentions here that 80% of product innovation and differentiation is now electrical, electronics, and software, which is interesting. And if we look at things like electric vehicles these days, they got new features built into them, like autonomous features where they can drive without human interaction. Machinery is becoming more advanced and moving towards the IoT world. Medical devices are becoming more advanced. And even consumer goods are becoming more advanced, like your fridges and your microwaves. Looking at this product lifecycle graph, we can also see there's pressure on manufacturers to bring their products faster to the market, but also keep their reliability and their performance up. But along with many manufacturers having to bring their products faster to the market, having their products to be more optimized, there's also pressure on these companies and manufacturers to meet compliance, meet the requirements, the rules, the standards, the governance and regulations that are around. And this is very critical as well. Well, okay, so let's look at electromechanical product design. And we have something here called the traditional approach. And what is this all about? Well, we can see it nicely in this picture here where the mechanical design teams on the left and the electrical design teams on the right are normally quite separate, and this can cause problems along the way. With this traditional approach, changes in the schematic or the design require rounds of exports and imports. Reviews need to be made by the mechanical or electrical engineer, and this could lead to unintended behaviors or delays or issues or problems along the way. A much better way of doing it is for every step of the life cycle in the design, from wiring schematics to 3D assembly and mechanical design, to have feedback in every single stage and have communication and integration at every single stage. This better way of collaboration and integration from mechanical design to electrical design is shown nicely here. And these are two pictures actually from Solid Edge design. And we can see here the mechanical design world and the electrical design world being brought together here. Let's take a look now at the different modules that are available for Solid Edge electrical design. And for electromechanical design, Well, we have this solid edge electrical design module. Underneath that, we have the wiring design, the harness design, and electrical routing. But the electrical routing also more falls under the mechanical design of the system. Going into some benefits for solid edge wiring design, we can see that it's very intuitive, very easy to use, and there are some great tools to make things much quicker. They're built-in libraries. The analysis tools for validation of errors and picking up errors. And the connector mode is really nice because we can actually connect the ECAD electrical world with the MCAD mechanical world and collaborate much better. Solid edge electrical design supports multiple standards. We can see for vehicles, systems, NC and IEC. Well, we've actually discussed a few benefits, and what I'd actually like to do is now practically demonstrate these benefits and do a demo. Great, let's open up Solid Edge, and I have an example project here from a company called WashTech. And if we open up this project, I'm going to go into the project, and we'll see how there are two different groups here in this project where I have schematics. And what I'd like to do is I'm going to open up one of the schematics here called servo motor, and we'll present some nice features here. In the schematic diagram, I have various objects here, and we can see on the left here, we have our libraries grouped here. We have design, symbols, parts, analysis, and groups. And under design, all our objects in our schematics are grouped together there. What I can do as well is using the middle roller button and drag, and we can zoom in, zoom out, and very easy to use that. What I can also do is select a particular object like a coil or a wire, and I can see that particular object in my design library, and I can view its properties. What I'd also like to do is to actually go into another diagram called power. And in the diagram, we have a contact and a circuit breaker again, and our live wires. Zooming in, and I select a particular label like B1, I can right click and select view related items, and by doing that I'm able to move between sheets very easily and navigate very easily. What I also have here as well in another schematic here, I have my motors here, and what you can see is when I select a particular contactor like KM4, I can see the properties of the contactor and all the contacts and the feedback contacts for that particular object in the library. What I'd also like to do is add a new motor here in the open space there. And what I'll do is I'll copy the condenser motor here with the contact. And when you copy it, goes it over the right position, which makes moving a bit easier. And what I can then also do is I can zoom into the properties of our motor here. And I can add some properties, like I can add a label, and I can add other properties like the kilowatts of the motor, and we'll make this motor 1.8 kilowatts. I've seen some many big motors over the years. I've seen some megawatt motors even, and that's quite a large range, but let's go for 1.8 kilowatts. And what we can also do as well with this motor, we can rename the motor. We don't want to call the motor condenser. We can call it maybe rotation. And after this, what I'd actually like to do is drag my wires across, and I would like to then, after renaming these wires, drag the wires from the contact at the top to the circuit breaker at the top. And after this renaming as well, we can then select our three contacts. But before we do that, we select multi-contact wire connect, and we can then connect all our three wires together and rename them. And as you can see, these are some really nice benefits. So it's very easy to use, and the renaming, the navigation, the properties of items and the libraries are really great to use. Good, so all our renaming is now done, and we can zoom out and we can see we very quickly added a new motor and some properties to that motor. What I'd like to now do is, let's go to another diagram, and it's a diagram called control circuit analysis. And in there, we're going to see some nice properties. In this diagram here, we can see switches. We can see normally open switches, normally closed switches. And as you can imagine now, this is a control circuit diagram for the WashTec station. So you can imagine bulbs and input switches and the main on-off switch as well, the main circuit there. And we have also a control unit here where we have different analysis tools built into it, where we can have our logic interface with our inputs and our outputs. Great. What I'd like to then do is, if we go to analysis and we select from the library numerical simulation, we can see all our objects here under analysis. And if we select play, we can see the states of those objects and those switches. And we can see here that our position of our door locks are open. Other positions for our ES1s and ES2s are closed. I want to make everything closed, and we can see then what the relating output will be. And you can almost, in a way, visualize this wash station being operated here. And it's a great way to verify your wiring logic and your electrical logic. And we can see here for one of the main control circuits here, is it closed? We can see our voltages, our amps, which is a great feature that. What we can then do is we can maybe hover over a bulb. We can see is the bulb lit or not? Yes, it is. We can also go into some switches like our door lock switch here. And we can open the switch, close the switch via the interface, and see what the relating outputs will be, and see our electrical circuits. What I'd actually like to do here is, going back to door locks, we can simulate a failure. And this is a nice benefit as well. If I select close and stuck open, which could be a failure of a switch, I can see what the resulting outputs will be, and the response of the circuit here. And all this is a great benefit for validating your electrical designs. Good. And there are many other things we can add in here. And that's really all I wanted to present to you. What I'm going to do next is I would like to go to another diagram. And we're going to stop this, and we're going to go to diagram number 1. And in diagram number 1, in another subsection, and this is the wash station wiring we saw earlier in that other control circuit analysis diagram, in a way, where we have switches and e-stops and bulbs and a light column. And right at the top, I've added 2 new wires, and these 2 wires are connecting to some connectors, and these connectors have pins. What I'd actually like to do is I'd like to assign some properties to these wires. Like I'd like to make one wire black and maybe a particular thickness. And from the search menu, I can select 0001, and we can add various properties in here. Very nice. And what I really like about this design as well is that when you add these properties for particular wires and connectors and whatever it may be, it creates a great bill of materials. And this bill of materials can also be used to generate reports and gather data. And that's really all I wanted to present there. We have our black wire and our red wire. Let's talk about solid edge electrical and going into harness design. Well, it's very rapid and intuitive. And if you look at the way harnesses are designed, normally they're actually laid on a form board, and the connectors are put in different ends, and they go along at different routes and different branches. But using solid edge electrical, it's very much automated, and it also validates the design, and it makes the reporting and generation much better and easier. Here we can see a diagram of the solid edge harness design, and we can see a layout here of the connectors, and it creates a bill of materials. It gives you a nice graphical layout, and it's the built-in intelligent part libraries, and the connector mode, as you'll see later, for wiring harnesses makes it really, really great, because you can actually see the lengths of the wiring harness. Is it going to be long enough? Is it going to stretch around the mechanical machine correctly? All those type of factors. So some good benefits here as well. We'll discuss some key benefits, but now I'm going to go into the solid edge harness design demo. Great. Okay, so let's go back into solid edge electrical. And what I'd actually like to do now is create a new harness diagram. And we provide some details for the diagram, like for example the name and the part number. And then we can also provide it with a schematic diagram name. like diagram 1. And also down below there are various properties we can provide for the diagram. And we can go to modify harness details, and underneath that we can choose various things like the manufacturing site. Is it Europe, is it United States, whatever it may be. What we can then do is also add some customer details into it. And there we go, we've got a selection list there. And what I want to do now is we've got our blank diagram, and we can also go and check out the borders of the diagram, edit the borders and add some features in if you want to as well, and modify the layout if you want. What I'd then like to do is I would like to start adding our actual wiring harness now. And now if you picture a wiring harness in your head, you can see that it consists of a sheath and wire bundles and clips and connectors and different branches. What I'd like to do is, from the menu, I'd like to add a static long bundle. So our longest bundle from beginning to end. And if you can imagine it as well, you can also see that there'll be different branches along the way, not as long. And at the ends of each branch, we're going to add some connectors to it. And let's add them in now. Great. So we can position it there in the right way, and I can also assign a length of that branch. Great. And we'll take it there right at the top, and we'll make some more branches from the bottom here. And it's quite really a tricky thing making a wiring harness. Can you imagine now for a vehicle how long these wiring harnesses can be, and the connectors that are involved, and they have to be just the right length, these wiring harnesses, and the different branches, and they need to also form and curve along the right way. And I'm going to add in one more wiring branch, and we'll add that to the top, and we can just also provide it with a length. Great, so this is our last wiring bundle or branch, and we can see it there going to the top. So now the next step is, at each end, we need to actually put the connector names. And these connector names we're putting in now, they link up with our other diagram that we created where we had our connectors and our wires, 2 wires that we added earlier. And this is quite a key aspect this now. And we've now put our connector names in, P1, P3, and so forth. And now, as I said now, we choose our other diagram here, and we assign the attribute for the wiring harness. And this is key. You need to do this correctly, otherwise it's not going to work properly. And if we right-click on the actual wiring diagram, we say synchronize, it pulls through all the details from our actual connector diagram into a harness diagram. And this is really nice. So we can see our connectors and our bombs for each connector and our wires. And this is really great. And now we can also form our different bends if you want to as well. And we can see now we can position things a bit neatly now. And I'll just zoom in a bit and adjust things a little bit. And this is really nice, because what we're seeing here is actually almost like a virtual form board that we actually created here. And we can manage our lengths and our bombs. And this synchronization really helped to make things and the connection much easier. And what I'd like to do is zoom in a bit more. We can see some details here, the wire details, the switch details, the connector details, and the cavities, whatever it may be. Great. Now the last bomb, we can position it in the corner of the sheet just to make it nice and neat. And there we've got it. And there we go. There is our actually finished bill of materials and our connectors and our actual diagram that we've got. So very, very nice. This is now where we get to the solid edge electrical routing. And it's the third module that we have to go over now. And with this add-on module, you're able to efficiently route your wires, your cables, your bundles, and your connectors along the 3D mechanical assembly. The connected mode for solid edge electrical design allows you to exchange data between the electrical design package in Solid Edge and the mechanical design package, and it makes things much easier for you. Let's go into now the Solid Edge electrical routing demo. Let's go back now into Solid Edge mechanical design now. And this is within Solid Edge Classic or Premium. And what I'd actually like to demonstrate to you now is the connected mode. And this connected mode is very nice because what we can do is we can have the mechanical design of the particular mechanical harness laid out next to our electrical design, and we can enable routing, and we can actually have the harness now on its own now. And I can zoom in and zoom out and look at the wires and the harness. And this is very nice because it's almost like when we have these two packages laid out together, as we see now, it's like having a digital twin of the process of design. And this is really, really nice. And now once we connect the mechanical package, yes, it's now connected. We have feedback. Now under workflow and the electrical package, we go Solid Edge Connect, and then we connect that as well. We have both worlds connected together here. And we can see this in green, the feedback message here, that it is connected. And now we can start checking a few things here. And what I'd actually like to do is, if you're a designer and you're designing a harness on a form board, you often have lots of connectors and wires and lots of root things. But if we cross select like we've done now from the menu, and we choose a connector like we've got over there, what I can actually do then, I can actually see that connector we've selected in the electrical design and match it up to the mechanical design. And these are some great benefits because it really does remove a lot of the complexity out of it. Can you imagine on a wiring harness on a form board, you lose track of where you're working or where the wire is that you're working on? There could be many wires, hundreds of wires maybe even, and this really does help. What I'm doing now is that those two new wires we added earlier, I'm clicking from the menu bridge out, and I'm sending an information on the two new wires to Solid Edge Mechanical. And by doing that, we can pull that new information through. It's almost like an update. And if we go to the mechanical design, we select update harness, it updates those two new wires we added. So it just shows you now how easy it is to actually add the new connectors and new wires to your system here. And we should see the new wires and connectors added there, yes. And we see our two new wires, but obviously we don't want those two wires to go along that route. We want it to actually route along the right path and the right bundle. So that's where Solid Edge routing comes into it. And what it actually does is you can quick select, we can select our two wires and automatically route those wires along the right bundle, right to the top, very neatly and down again. And then we should see our two black and red wires we added earlier going to the connector. And this is really all nice, because as I said as well, it really does remove a lot of complexity, and it saves time out of it as well. And now we can see at the bottom there, our two new wires are connected. Of course, we're going to do a bit of neatening up along the way. That's normal. We're just neatening up those two little wires going into the connector there. And also, what's quite nice here, we can see what the actual connector looks like in the mechanical design. And yeah, we're just routing those again very neatly into the connector there. Now, what I'm going to do next now is we have our black wire. You can see our mechanical structure, our red wire, and we see our e-stop very nicely. So it's like a digital twin. But now what I want to do is I want to update one of the wires on our electrical design now. And one of those wires over there. Not that one, that's the black wire. But as you can see here, very nice. We can see the true lengths of these wires. Now that's really nice, a good benefit that. Because when you're designing a harness, and if you don't have the correct length, you have to cut those wires, relay them again, and that's quite difficult actually. So let's go back to the electrical design, and now we can see here, zooming in, the one wire to the second pin. I'm going to adjust the properties of that, and instead of making that wire red, I'm going to use and make it blue. And then we're going to update that and send that through back to our mechanical design. And let's just do that. And just to represent to you how easy it is to update the two different interfaces. And what I can also do as well is selecting all the wires. I want to add a new property. I can get feedback from mechanical design on the true wire lengths into the electrical design and update my BOM on the wire lengths and also how much wire I need for each different line. And there we have it there, and we can align that quite neatly. And if we had to select bridge in, we can update that information from mechanical design into the electrical design. And so just for the blue wire now, we've added there. So now I'm saying bridge out, and now if I go update again, update harness, we should see our blue wire, and we can go into the design and see our true lengths again. And there we go, and we can now see our true length. And if I zoom into my actual design here, great, we can see our whole structure there and my whole actual harness there, and zooming in and out using the mouse, get a nice view of all that. Good. There we go. That's pretty much the design I wanted to present to all of you. This particular slide about the electrical design workflow is pretty much what I presented earlier, and it just talks about the electrical and harness libraries that are available. And it talks about how you can actually connect the solid edge wiring design and the harness design through via connected mode to the solid edge 3D CAD environment. And this is really, as I presented earlier in the live demo, a nice feature. Let's talk now about collaboration, and specifically for data management. And a really nice feature that I also like as well for collaboration and data management is Teamcenter. And with this, we can actually create and manage electrical projects. We can control user access, versioning is available, and user management. And also at Teamcenter, there's an active workspace available that integrates directly with Solid Edge, where you can share BOMs and you can actually from mechanical end or electrical end. What I'd like to also mention here is that with Solid Edge electrical design, we also have Solid Edge PCB design for circuit boards, and this also integrates very nicely with the mechanical MCAD design of the circuit board, the microchips and components with the electrical design. And it's a really nice integrated feature that's available. This is a great reference for Solid Edge Electrical, and this is from the Vice President Chief Engineer from Radiobo Corporation, and his name is Eric Becknell, and he writes here, he says, integration of mechanical and electrical design tools with Solid Edge will enable us to develop and deliver our custom electromechanical system faster and at a lower cost than our competition. So great benefits there. Let's go through now a few of the new features that are available for Solid Edge electrical design. Well, there's a lot to talk about in electrical design, but first let's talk about wiring design, and this is really important. And we can see here within Solid Edge 2021, the cabinet panel design feature that's been added in now, and this is a whole different story now, because wiring a tractor or a vehicle is quite different to wiring an electrical control panel, and this feature really adds some nice benefits into the designer, and it's 2D panel assembly design. We're looking at some more new features here for wiring design. The amount of productivity that you can have in terms of laying out the cabinets and the panels is really quite remarkable. And you can have customizable table-based views for terminal strips. And you can have devices that are snapping to rails automatically. And there's also an interactive auto route enhanced feature. And it was quite nice. We can have upward compatibility into the Mentor Capital environment, enterprise environment. Looking at electrical routing and some new features, you've got a glimpse of what electrical routing would look like along irregular geometry. But now with the new feature for electrical routing, it can even be sculpted along its shape. And also with this new connected mode, it can be extended to Capital, which is our enterprise design environment. So talking about some new features for harness design. In the area of harness design, to be clear, when I talk about harness design, I'm not just talking about the 3D efforts that the mechanical engineer might think of. Harness design is also something you do in 2D, and how you're going to actually lay out the harness for production. And there's some nice features here, like for Teamcenter, for bidirectional linking and viewing in Teamcenter. And also auto routing is now available for the full signal path. So very, very nice. In the area of PCB, there's some great stuff as well. And it's all about collaboration between the electrical and mechanical and the ability to bring the design aspects back and forth. Maybe propose a design change and accept it or reject it. And this is all done through the IDEX 2.7 format, which is the Expedition package. And with interfacing to Expedition, we can do more advanced things like thermal analysis of circuit boards. We can do track routing, and there are many other nice features. Let's now go back into Solid Edge Electrical and practically demonstrate some of these new features that are available. And what do we see here? We see our electrical design, and we see some connected sheets with it. And we've got contactors and circuit breakers and isolators and various things like motors. What I'm doing now is I'm making a new panel layout diagram, and we can provide various properties of the panel. And for this panel, I'm adding a backplate. And on this backplate, we can add some dimensions, and we'll add our trunking and our channels and our DIN rails to that. And we can select different DIN rail properties, what type of DIN rail we're actually going to use here. And then we can nicely position it and just make double sure everything's correct. What I would like to do now is there's a nice feature from the menu called Associate Designs. What this actually does is you can associate this panel design with your electrical design. And by doing that, under the library, under groups, we can see that tab there where all our electrical components in our electrical design are listed there. And we can add them, and they snap very nicely to the DIN rail in their relevant groups. And this is really nice, this feature. And they're positioned correctly. We have our overloads or whatever there's going to be there, and our terminal strips are laid out very nicely. And we see our BOM also correctly laid out there. This is all great, and what I can do here is I can add a terminal strip view, and by doing this I can see which wires connect to which terminal strip. What is the name of the wire? What is the schematic drawing number name? And the voltages and wire numbers and many other features. Now what I'm going to do is I would like to go and actually view this electrical diagram against our mechanical machine, and this is called a Finamac popsicle machine. It makes ice cream popsicles, and we have our electrical diagram here on the left, the mechanical diagram on the right. And using connected mode again, and the new auto routing feature, we can route between two electrical panels very nicely and easily. And it's very nice because it's actually non-linear routing, and we can automatically route it against the right path and through the grommet out and from the one panel to the other. And we just position it correctly, and there we go. It's now done nice and neatly there. And there we go. There's our popsicle machine wired up and done, and our wiring completed. And we can look at other properties if we want to as well, but that's pretty much about it. And there's our completed popsicle machine. Just the last few things to keep in mind. If you're interested in this demo project and you would like to have some more detailed information, I can provide you with a walkthrough, step-by-step guide of this demo project. If you'd like a free trial, you can also contact me in that regard. And lastly, if you're interested in robots and design and building things, then we have a very nice example for Build Your First Robot, which is using the award-winning Bumblebee robot from Israel, where you can actually do some nice electrical routing. And finally, I'm open to any questions that you might have from what I presented here today. Along with any questions you might have, I would just like to say thank you very much from me and Kaizen. for joining the webinar. And my contact details are actually here below, my email address and my number.